Hello, and welcome to my YouTube channel. And in this episode, we're going to get around to the long delayed part two of building the O-scale Whitcomb switcher using a combination of scratch building, 3D printing, and laser cutting. I was able to kind of create this two-axle, four-wheel little industrial critter in O-scale, not Proto 48, but O scale. I am working on a second one that's Proto 48. But this is based on a Whitcomb, I think it's a 45-ton locomotive. I talked a lot more about that in part one. And the reason that I picked this as the subject was because there was an HO print available, or an HO file available that was posted online. Very well done. STL to print in that we printed in resin. It was an HO scale model, so we scaled up. This is something that online you see a lot of posts about, what percentage do I use to go from HO to O scale or this or that, and in my opinion, a lot of that's just overcomplicated. The easiest thing to do when you're scaling anything in for 3D printing or what have you is to just go up to the original size. So for this model, you just can, in the HO, we knew it was 1/87th, so multiply whatever the measurement was in HO scale by 87 to get up to the prototype real world size. And then you're going back to O scale, which is 1/48, so it's 48 times smaller. So then just divide by 48. And then usually you have like a scale function in your slicer in your 3D printer that you can just scale the model by changing the one measurement, but all the measurements are linked together. And that's how I do everything. And even if I'm I'm using an HO scale model to go to O scale, I do it the same way. And a lot of times I'll just measure with a digital caliper. I do everything in metric because my laser cutter and my 3D printer are both based in metric. So I need to scale to metric. And if I'm going off real world measurements, I have to go from feet to inches and then from inches to millimeters, which isn't hard to do. 25.4 is the factor that you multiply an inch by to get how many millimeters. So it's real easy to do. A lot of just calculator math, but nothing complicated. So for this model, when I started off, I had to create a scratch build drive system, and I had a bunch of these that I got on sale somewhere. They were Tamiya, like kind of science kits that were different types of gearboxes, and I figured someday they'd come in useful for animating a model or some kind of factory animation in the steel mill, something like that. But then I started playing around with it and the gears and the axles that came with it. I said, well, I think it's 4mm axles. Everything's based on. I could maybe use that to drive a small, critter type O scale locomotive. So I kind of went to the CAD drawing board and started creating like some files. I always knew I was going to kind of laser cut the frame for this model. And so I started playing around with kind of different, how to fit the motor. It's a tight space in there with the hood and everything. So how to fit a motor and the axles and the gears and all that stuff. So it's just a lot of CAD, going to CAD, laser cutting pieces, going back to CAD, laser cutting, on and on and on. I did use Intermountain wheels, which might be a tad too small. I think they're 33-inch wheels, and the prototype I'm going to guess was maybe 36-inch, although it could have been 33-inch. I think I might have read somewhere that it was 33, and so I felt pretty good that I was, but I'm not 100% on that. There's not a lot of information about these locomotives out there. So you can see me mocking things up and check, I'm using those collars, which you can get at a radio-controlled airplane or car store. They're pretty common. You can order them on eBay. It's kind of like, to hold the axles in place and just press fit on the wheels. And you can see that part that sticks up is kind of juts into the cab of the locomotive, and that's designed to hold the motor, which is just a really cheap, crappy, like one of those toy, open frame kind of motor. It's not open frame, but just it's not brushless or anything like that. It is certainly not a Pitman motor. And I only set it up to drive one axle, which, later on that was not the smartest thing, but, I was working on maybe a chain drive to upgrade this, but then I ended up, you'll see later on that I went in an entirely different direction. So now you can see I'm kind of fitting it into the space in the locomotive underneath. And essentially the wheels and the axles are independent of the frame of the locomotive. So it's just, the whole power assembly just is a drop-in kind of thing. And there you can see the motor, and that was really tight, the clearances. I think I had to go back a few times with that and change the angle, kind of clip the corners, just trying to get that it would fit inside the cab was kind of a nightmare. But I was able to get it all, kind of put together. You can also see the quality of the file with that print there. It's an awesome, well done 3D file, and even better that the guy posted it for free. I talked about him and the file and everything in part 1, so go back and watch that if you need to find the information on that. And these gears are, I think, Delrin gears, and they seem pretty durable. The motor itself has a much smaller shaft than all the gear shafts. It's just one of those really tiny, maybe like 1 millimeter or 1.5 millimeter shafts that's coming out of the motor. Maybe 2 millimeter, I'm not sure, but it's small, and you basically just press on the gear, so everything's just kind of a press fit, and which I figure eventually that might or might not be a problem when I was doing this. And again, I this isn't the final drive. It did work, and I got it functional. And it did pull cars on the level, and I figured I could improve it by adding a sprockets and a chain to power the second axle. And I was also going to add some weight before I went in the different direction. So I felt that there were options to improve the drive, and it at its core, it did work, and it did pull cars. I'm not sure how it would have handled the grades at our club. And you can see you get a lot of parts in these things. And again, I got them on sale somewhere, and they were like 50% off. So they were maybe like $9 or $8 for like one of these boxes. And you get all these gears, motors, shafts, all kinds of stuff. They're great. They're great little kits, even if you got to pay full price for them. So you can see me there. I'm kind of mocking it up, and I got it attached to a power supply and playing around with it, and it's kind of, I think it's about to work, but I'm not certain. And but just monkeying around with the motor, and again, a lot of it has to do with the spacing. There you go. With the gears, to make sure you have an appropriate spacing between the gears. I wasn't doing it very scientifically. I was just doing it by trial and error, kind of like the Thomas Edison with the light bulbs. Just keep throwing shit at it until you find the right fit for the motor where everything worked. Again, this motor, this was designed to basically work off track power. The design I eventually went with is 100% battery. There was no way I was going to probably fit batteries in here, and with this setup that I had, because I barely had room to fit the batteries in the eventual locomotive, and that had nothing above that deck as far as motors. Well, it did have a little bit, but not much above the deck when it came to motors. So that's where I kind of ended it, and you can see there's cutting out parts of the laser. The laser's great because the laser is 100 times faster than a 3D printer. So you can prototype parts, put it together, redesign it, print it out, and you don't have to wait like 3, 4, or 5, 10 hours for the print to finish before you can test it to see if what you did worked. So lasers are as useful to me, laser cutters, as are 3D printers. They both have their places, but like I said, I'd kind of be lost without either one of them. So they're very important. Again, it got it to the point where it was pretty functional. And there I added, you can kind of see I added I started experimenting with track pickups. So it's just basically phosphorus bronze wire soldered to some little circuit board pieces that then bolt through to the frame. There's the wires come off of them to supply, it would have gone to the decoder and then another wires to the motor. Like I said, it did work. I was pretty proud of myself that I got a functional locomotive because I had never really done anything like that before. I'd always used commercial drives or modified commercial drives. I'd never done something where I built something from scratch. Although what happened was, I built it and I was like, okay, mission accomplished. But it wasn't as bulletproof as I would have liked it, and I felt like even with spending a lot more time with the chain drive and the weights, that I wasn't going to end up with something that I was going to be happy with, and that could pull cars, pull enough cars up hills. So I kind of set the whole thing aside and didn't do any work on it for probably about a year. I put everything in a box like a bin. I kind of store my projects in bins. So I put everything in a bin and it just, sat there, and I thought about it. And then what happened was I'm on a variety of Facebook groups, and one of them's a Proto 48 group. And there's a fellow on there, Jay Criswell, I believe I'm saying his last name right, who he sells a lot of parts, like track parts for through Proto 48 modeling, and he also does a lot of work with engine drives, repowering drives. He builds drives for people, knows everything about locomotive drives and machining locomotive drives, and really, really builds elegant pieces of machinery, way beyond anything I would ever be capable of. However, he posted a few photos of him using these gear drive motors, these cheap Amazon gear drive motors to repower. I believe it was like either a 70 tonner or a G 70 tonner or a G 44 tonner. And that kind of got me started down the road with, hey, maybe that's the way to go. Maybe I should try these gear drives. So I ordered a few of them. They're really cheap, I think less than $10 a piece off Amazon. And I started fiddling around with them, and I started to test them out and pull the Whitcomb back out of the box, and and then that's where I would go and call it version 2.0 of the Whitcomb drive. Still the same shell, and again, I hadn't done much because I didn't want to invest a lot of time into this thing if I wasn't going to have an operational locomotive. I didn't want just a static display locomotive. So here's one of those N20 drives that I was talking about, and you can see what I did was to connect the axle to the wheel. The axle on this N20 is a little short for O scale. Since I did this, I found same version, longer axles. These motors also come with different voltages and also different RPMs, but most of them are geared very low, so like under 1,000 RPMs, and most of them are like 60 to 200 is what I'm usually working with. And I determined about what I needed as far as, doing a bunch of calculations with wheel diameter and circumference and scale miles per hour, blah, all that. So you can see now I'm back to square one, though I have to design a whole new frame and a way to hold the motors in place and hold the wheels. And like in that earlier picture, a few pictures ago, I created kind of a 3D resin printed bushings to fit on the end of the axles to transition to the intermountain wheels. Right there is one of the bushings. The axles on these have a flat part, so you can get a good positive thing. But I was fiddling around with these bushings. These original bushings didn't end up working as well as I'd like because when you press the axle or the wheel onto them, you couldn't get a perfect, something that would have, a dial indicator would have given you a perfectly true wheel. So I felt like I was getting a little, I don't know, wallowing around on the wheels were kind of not true. Although it did run fine. It might have just been looking at it, you could see some little minor imperfections, but it actually, I'm not sure it would have affected the operational, capability of the locomotive. But I did end up redesigning those bushings and creating a kind of a collar, like a wide collar on them to go flat against the back of the wheel to kind of give you that perfect 90 degree positioning you want and to kind of brace the wheel. So when it came down to mounting the motors, there are some mounting holes, like some threaded holes on these motors, but I think it's a 1.6 millimeter screw, so kind of small to work with. And I don't know how I came up with it, but at one point I just said, I wonder a zip tie would work. And I basically just added some slots to the frame and just wrapped the zip tie around the motor and kind of pulled it up. And the gear part of the motor is square. Like you can see right there, it's rectangular, where the top is like that rounded shape. So by using two pieces of acrylic there that are laminated, the one has a hole for the rectangular section, and then the other has the hole for the motor section, and then the slots. Doing that, the whole thing just kind of, with the zip tie, it just locks it all together. And basically what I did was I just used a zip tie and had the end part, I don't even know what that's called, and just pulled it around and then just slid a second zip tie onto the other end that was sticking up through the piece to kind of lock it together, and then just clipped all the excess off. And in the meantime that I realized this was going to actually probably work, I started adding some details to the locomotives. I created some 3D files for the pipe fittings on the railing. I created there's some kind of tank on the prototype, that external tank. I created that. I created door handles, windshield wiper things, I don't know, at least a half dozen or more little detail parts I designed in 3D CAD and then printed them in resin to kind of dress up the locomotive. You can see there's a coupler bar, and again, just dressing it up as much as possible while at the same time working on the drive system. And I decided at this point that the drive system, I was going to try to do battery, which I wasn't sure I was going to be able to do because the hood is so small. This is a small locomotive. And so I started playing with what I could fit inside the hood. This is looking up into the hood there, or, what can I fit in there? How can I, arrange things, that sort of thing. And I knew it was going to be a tight fit, and I went to a local hobby store called, I think it's Trains and Lanes in Nazareth, Pennsylvania, near Easton, PA. And they have, they're huge in radio control cars. So I figured they would know. And I went in there and said, look, I need a 12-volt battery that can fit in this space. And they're like, nope, you're not gonna do it. I gave them the measurements, and they said the only thing you're going to fit in there is a 2-cell battery, not a 3-cell battery. And a 2-cell battery is 7.4 volts. So I quickly looked up on my phone, because I was going to use a Bluenami decoder, what the low end voltage that I could work with. And I believe it was around 6 something is the low end. And so I was going to come in around 8, fully charged. And so it didn't end up having a problem at all. Although my maximum voltage is only maybe 7.5 volts. So I can't, but this isn't a locomotive that I'm going to go at high speed for anyway. So now you can see me fitting things on the bottom of the frame here. The little blocks on the ends are for magnets to hold the frame to the body. I've added an on-off switch so I can disable it from underneath without having to take the shell off. 2 sugar cube speakers in the middle for the sound from the decoder sound, and then a charging plug that charges it has an adapter that goes to a USB that you can charge off USB. You can see the couplers are attached to the body, not the frame, and you can also see those bushings I created for the wheels to give me that backing to keep the wheels rotating in a nice true fashion. It's just everything kind of just fit in there and worked out well. I barely fit it. There's the USB charger to charge it that you can just plug into a computer, a phone, a USB transformer adapter that plugs into the wall, whatever you want to do. And I don't have to take the locomotive apart because with the lights too, there's directional lighting. It's kind of a nightmare to take it apart. Oh, and there's a directional strobe too. I added a strobe with a little LED, created like I think a little 3D housing for that. You can see the strobe flashing. So this is the battery power here, basically. I'm running across the floor of my workshop with the locomotive, testing it out. And it'll run anywhere. So now that everything was going to work, I got to paint the locomotive. So I taped up the parts I didn't want and took out the drive, and it's in the spray booth now, getting sprayed. All the lights, so there's forward, reverse, and then the strobe lights all have mini plugs on the end of them, so I can disconnect the drive, the frame with the decoder on it from that. So I initially painted it a kind of a bright orange that it was the only orange that this local hobby store had, and it was like Mission Models or something like that, and it was kind of shit. The paint it actually like peeled a little bit. Did not like it at all. I usually use Vallejo, and the Vallejo store was not close by. But in the meantime, I took it to my train club. To kind of see if it would make the grades, because we have some pretty extreme grades, as you can see at my O-scale train club. So I'm testing it with, those are weighted cars too, so those cars have some weight in them. They're not like empty cars, plastic cars. They're weighted. So I wanted to make sure it could get up these grades, and it did. It performed fine. I think 3 cars seemed good, and maybe like 4, I think, was kind of pushing it. But this locomotive, honestly, probably would have only been able to call one of those cars up a grade like this in the prototype. And so then I weathered it, created glazing for the windows. I couldn't do a cab interior just because I got so much with the batteries, the decoder, all the wires and on-off switches and charging. There's no way. So unfortunately, I wasn't able to detail the interior of the cab. So small trade-off for a functional locomotive. And, I was very, very pleased. It runs great. The charge lasts like forever. Now you can see some more heavy weathering. I had it like a shovel and pail, some tools. That air tank, which is on the prototype I was modeling, which was a U.S. Steel locomotive. I'm not sure if it's a supplemental like air thing or some kind of heater. I'm not sure. I think it's got to do with the air brakes and the air tank, because it probably doesn't have a compressor on it, or the compressor was broken. So they added a big tank there just to deal with the air system on the locomotive. So I'm going to leave you with this. This is the final picture of the locomotive. Thanks for watching. I'll try to answer any questions. I don't know if I fully explained how I did everything, but hopefully give you a starting point on building like an O-scale locomotive. Don't be afraid to try. Even if you don't have some of the tools that I do, give it a shot. Take care, and thanks for watching.